This is a rainforest. Now, rainforests are home to more than half of the plant and animal species in the world. In fact, this fern plant is only found here in this rainforest in Hawaii. Now, a rainforest is a climate that's warm and wet. It's great for growing things. It's a beautiful climate.
Hi, I'm Anna Zolbrod. I look at how climate change might affect the distribution of plants across the landscape. Plants grow through temperature and precipitation. As these factors change, then the ability of plants to grow effectively in a certain area will change. We already have signs that the climate in the past 100 years or so has warmed quite a bit. We can see this from little tree seedlings like this invading meadows at the edge of forests, where before trees couldn't grow because it was too cold. This is a great big old fir tree that grows near mountaintops, and it should have a good long record of past climate changes, because if it was a warm year, say, it may grow a lot more than if it was a colder year. Now I'm coring the tree in order to get the record of the rings. This doesn't hurt the tree at all. You can just see the bark coming out now. These are pieces of the core that we just pulled out from the tree. It's a slice of the cross-section of the tree. Trees grow from inside to out, and so each ring represents a year's growth. There are some years in which the tree grew really fast, where you have fat rings, and then some years where you have skinny rings, where it grew more slowly. So the more we understand about how climate change affects the world around us, the more we'll be able to respond and keep our forests growing healthy, keep the species intact. It's really important to study climate change effects.
Hi there, I'm Bob, and welcome to This Old Climate. Let's come on down here. Watch out for that hoe there. Here's Heidi down here working on the A-frame.
Hi, Bob.
Oh, hi, Heidi. This is coming along nicely. The A-frame's going to be perfect for the wet and snowy Swiss climate.
Ja, the A-frame will help in the snow and falling off in the roofing.
Ja.
Ja.
So, Heidi, to demonstrate how this works is, as snow falls, you notice it doesn't accumulate up on top of the roof. It goes down the sides of the roof and onto the ground so your roof doesn't cave in. Very smart.
Ja, ik ben een smarte huis beelden. Ja.
You enjoying that, Heidi? See, it's going right down the roof.
Right it down.
Right on down the roof.
To the flooring.
Climate is how warm and wet a place is. So it's true of small places like islands. It's also true of micro places like the side of this tree. See, the moss grows on the north side where it's cooler and wetter, but where the sun shines brightly, the moss doesn't grow so well. This is a microclimate. They're everywhere. See this tree? All the roots are exposed. And look at all the stuff growing on it. So you don't find a tree like this just anywhere. No, you find a tree like this in the tropics, where the climate is warm and wet. Wet, see?
Like, why would I want to live anywhere but the tropical rainforest? It's like so warm and wet, and like, that's the only place I'd want to be because it's like the perfect climate. Tell me that Tiffany has such an attitude about latitude. It's like, I just want to say, chill, polar ice cap girl, okay? If you want to live in a cold, dry climate, that's okay with me. But you don't have to be so frosty to all your friends.
What's in the atmosphere helps control our climates. Take a look at this. Take a look at this. Take a look at this. It's our atmospheric warming tank of science. Now, on this side, we have nothing but regular air. But on this side, there's almost nothing but carbon dioxide. Carbon dioxide. Carbon dioxide. Here, I'll show you. If I take a match, let it burn, it burns fine in air. But in carbon dioxide, CO2, it goes right out. Carbon dioxide puts it out, just like water. Now, carbon dioxide is heavier than air, so it stays in this side of the tank. Now, take a look at the thermometers. The one on the air side is reading around 20 degrees Celsius. But the one on the carbon dioxide side is reading a little bit higher, just a few degrees warmer. That's because carbon dioxide is a gas that helps hold in heat. So carbon dioxide in the world's atmosphere helps keep the world warm. It holds in heat. Without it, the world would be freezing cold. Here's the thing. Right now, we're pumping billions of extra tons, billions of tons of extra carbon dioxide into the world's atmosphere every year. Billions of tons of it every year. It comes from cars, trains, and planes. It also comes from forest fires. People are burning down forests to make room for farms. But here's the thing. If the world gets a little bit too warm, then the level of the oceans may change, and the world's climates may change just a little bit. Just enough to make it impossible for us to grow enough food for everybody to eat. So we need some carbon dioxide in the atmosphere, but not too much. Now this process of extra carbon dioxide and extra other gases in the world's atmosphere is part of what we call global warming. Global warming. The globe is getting too warm, and something we've got to be careful of. Otherwise, things could get weird.
Igloo Dollhouse, the latest in climate-controlled kiddie fun. That's right. For just $29.95, you can own this Igloo construction kit. Just add water, stick in the freezer overnight, and come morning, you'll have all the parts to make an Igloo Dollhouse. Some assembly required.
Igloo! Steve Poole joins us now. We've had a lot of changes around here in our weather, and this time it looks like it's going to get even colder.
Yeah, a little bit more cold, so now we have to watch things a bit more closely. Now, I want to emphasize here that we're not talking about a concern for all of you, or even that big a concern, but it's something worth mentioning, so let's do it. It is much more difficult to do the weather than it is to put a man on the moon. The math is much more complex, which kind of explains why we blow it sometimes. Maybe one way to think of it is think of the atmosphere as being like a river, only it's a river of air instead of a river of water, and it's constantly flowing, right? And we have these areas where you have higher pressure and lower pressure, and all of these things are moving, and as it moves across the globe, it changes the weather for everybody. So you may have a certain climate in your area, so you're, like if you're in the desert, it's probably more dry there. If you're in the Northwest, it's probably more wet there. But overall, you keep getting change because that river of air is constantly in motion. It's obviously important that I know about the weather in just my community that I forecast for, but you also have to know about the entire country and the entire world because it's all linked together. Nothing happens here where it doesn't have an effect someplace else, so you have to be aware of that. All of the climates are linked together. You can't separate them.
I was right.